In this video, we're going to look at some coordinate geometry problems that involve parametric equations. Okay, so generally, if you're using parametric, or you're looking at problems involve parametric equations, you might have to work out where the graph crosses the x or the y-axis. You might need to work out where a curve given as parametric equations intersects another graph. Okay, all of these we can do using the parametrics. In the previous video I showed you how to convert to Cartesian. I would say in general, if you're solving coordinate geometry questions, it's easier usually to use the parametrics. I would only really ever consider converting to Cartesian equations if the question told me to do that in the first place. Okay, so otherwise, if it doesn't, then use the parametric equations. Okay, so remember, when you've got a pair of parametric equations, the parameter, whether it's t or theta, you can think of that as a sort of go-between between the x and y coordinate. So if you know the value of the parameter, then you can use that to work out the x or the y value by substituting it into the relevant equation. If you know the x coordinate, then you can use that to get t, which you can then use to get y, and vice versa. Okay, we're going to look at 4 questions in this video. The first 3 are relatively straightforward. The fourth one is a bit more complex. Okay, example 1. The diagram shows a sketch of the curve with parametric equations x equals t minus 1, y equals 4 minus t squared. The curve meets the x-axis at the points A and B. Find the coordinates of A and B. Okay, so we know that a graph has x-intercepts where y equals 0. So I'm going to set my y parametric equal to 0 to find the value of t where y is 0. So if I say 4 minus t squared equals 0, then t squared will equal 4, which means t must equal plus or minus 2. So I know that when the y coordinate is 0, the value of the parameter is 2 or minus 2. So now I know that, now I can work out the x coordinate when t is plus or minus 2. So if x equals t minus 1, then when t is 2, x will equal 2 take 1. So that means there must be an x-intercept at 1, 0. And then if t equals minus 2, x will equal minus 3, which means there must be an x-intercept at minus 3, 0. And then looking at my diagram, that must be B and that must be A. Okay, the next question. The diagram shows a curve C with parametric equations x equals at squared plus t and y equals a lots of t cubed plus 8, where t can be any number and a is a non-zero constant. Given that c passes through the point minus 4, 0, find the value of a. Okay, so we know that when x equals minus 4, y equals 0. So we know when x equals minus 4, y equals 0. Okay, if I substitute minus 4 into this one, then I'll have minus 4 equals at squared plus t, which means I will have one equation with 2 unknowns. So that's not going to be massively helpful at this stage. if I set y equals 0, then I can solve that because I'll be able to divide through by a, which will disappear, and I'll be able to figure out what t is. So I'm going to do that first, okay? If that wasn't obvious, then what you would do is, again, I guess you would just try them and then see what happens, okay? So all you can do at this stage is substitute -4 into the first one and 0 into the second one, okay? You'd soon figure out that the first one isn't going to massively help you at this point, okay? We will need that later on though. So I'm going to substitute y is 0 into the second parametric. So I'll have a lots of t cubed plus 8 equals 0. If I divide by a, I will have t cubed plus 8 equals 0, which means that t cubed equals -8, which means t is the cube root of -8, which is -2. Okay, so I know that at that point there, I know now that t is -2. So because I've got the value of the parameter at that point, I can now use that as the go-between to work out what a is by using the first parametric, because I know when t equals -2, I also know, as well as y equals 0, I also know that x equals -4. So I'm going to say, when x equals -4 and t equals -2, I'm going to now substitute that into here. I'll have -4 equals a lots of -2 squared, take 2. So -4 equals 4a, take 2. If I add 2 to both sides, 4a equals -2. And then if I divide by 4, I will get a equals -2/4, or a half. And that's that one. Okay, so all I've done for the first two questions is I've just interchanged using that parameter as a go-between between the x-coordinate and the y-coordinate. Okay, the next one's a little bit different, slightly. In fact, I'll just go back because I've realised I've not done part B. So that was part A. Apologies. So that was part A. I found the value of A. Now we need to find the coordinates of the points A and B where the curve crosses the y-axis. Okay. So I've just gone back to example 2 because I hadn't finished it. So I want to know where the curve for part B is crossing the y-axis. Well, the curve crosses the y-axis when this time the x-coordinate is 0. So I'm going to use the first parametric equation and set x equal to 0 to solve for t, and then I can use the t to put it in the y parametric to get the y value. So it's just the reverse of what I did on the first example. So I know that a is -1/2, so -1/2 t squared plus t equals x equals 0. Okay, I can take out a factor. I take out a factor of t. Oops. I'm not entirely sure where that came from. So t brackets -1/2 t plus 1. So t will be 0 for one solution, or -1/2 t equals -1, which means that t must be 2. So I've worked out when x equals 0, the values of the parameters at a and b are 0 and 2. Okay, so I'm just going to pop those now into my y parametric. I know that y is a, which is minus a half, t cubed plus 8. So if I put t0 in, I will get y is negative a half times 8, which is negative 4. And if I put 2 in, I'll get y is negative a half times by 2 cubed plus 8. 2 cubed plus 8 is 16, times by negative a half is minus 8. So we've got two y-intercepts. We've got 0, minus 4, and we've got 0, minus 8. And I can see from the diagram that that must be A and that must be B. Okay, that's the end of that example. Example 3. A curve is given parametrically by the equations x equals t squared and y equals 4t. The line x plus y plus 4 equals 0 meets the curve at A. Find the coordinates of A. Okay, so we're looking at where the graph given parametrically intersects the line. So usually, if you just had two Cartesian equations, you would solve those simultaneously. Okay, again, if we wanted to, we could find the Cartesian equation of the parametric curve and then use that with the line, but we don't need to. Okay, what I'm going to do here is I'm going to substitute my parametric equations into the line. Okay, so just in the same way that when you're solving Cartesian simultaneous equations, you would substitute one into the other, I'm going to substitute my parametric equations into the line. So instead of x plus y plus 4 equals 0, I'm going to have t squared plus 4t plus 4 equals 0. And you can see that I've got a quadratic in terms of t, which I can factorise, or you could use your calculator if you were desperate. Factorises to t plus 2 times t plus 2, which means that t equals minus 2. Keep pressing things with my hand. Minus 2. So that's the value of the parameter at the point where the line intersects that curve or whatever it happens to look like. Okay? If we want the coordinates, remember we want normal coordinates, so we need an x and a y value, we can substitute then t equals minus 2 into each of the parametrics. So at t equals minus 2, x will be minus 2 squared, which is 4. And when t equals minus 2, y will be 4 times minus 2, which is minus 8. So the point of intersection will be 4 minus 8. And that's the coordinates of the point A. Okay, so those three questions were relatively straightforward, nothing too taxing. Okay, the next question, there's a bit more to it. For one thing, it involves trig. Secondly, both the parametric equations are a bit more complex. And thirdly, we've been given this. So this is the domain of the parameter. So each of these two parts of the question, we need to consider the domain of the parameter because we're going to get values for t some of them might be outside of that range. So anything outside of that range of the parameter, sorry, the domain of the parameter, I should say, anything outside of that, we need to disregard. Okay, so pay attention always to the domain of the parameter. Right, part A. Find the point where the curve intersects the line y equals pi squared. So we've got a curve given parametrically, we've got the x parametric, and we've got the y parametric. We know that the curve is valid when t is greater than minus pi on 2, but less than 4 pi on 3. So that curve, that weird looking curve, is only valid for t values between minus pi on 2 and 4 pi on 3. We want to find the point where the curve, given with those parametric equations, intersects the line y equals pi squared. Okay, pi squared is just a number. Pi is 3.14, so pi squared is just over 9. So that's just a horizontal line, so it might be up here, for example. Okay, so we're looking for the point of intersection. Okay, I'm assuming it's not down here, purely because it says the point of intersection. So I'm assuming it's higher up than the other one. Okay, find the point where the curve intersects the line y equals pi squared. Okay, so that has got a y coordinate of pi squared. So what we need to do is substitute that into our y parametric. So we're going to say t minus pi on 6 squared, squared equals pi squared. So I've just set my y parametric equal to pi squared. If I square root both sides, I'll get t minus pi on 6 equals plus or minus pi. Okay, so t, if I add pi on 6, t will equal positive pi plus pi on 6, which is 7 pi on 6, or it will equal negative pi plus pi on 6, which is negative 5 pi on 6. And now I've got two values for t, but what I'm going to do is I'm going to consider my domain of the parameter. Negative 5 pi on 6 is close to negative pi, which is outside of that range. It's too small, too negative. So that one we can reject, and that is our one value for t. So all we need to do now is substitute that value for t into x. So if we say x equals cos of 7 pi on 6 plus sine 7 pi on 6, that's going to give us the x coordinate. Okay, that's going to give us, if we type that into our calculator, if we're in radians, it will give us negative 1 plus root 3 over 2, which I can keep as an exact value. And we know that the y coordinate is pi squared, because that's what we solved in the first place. So the point of intersection will be negative 1 plus root 3 over 2 pi squared. That's the answer to part A. For part B, it says find the coordinates of the points A and B where the curve cuts the y-axis. So again, this is the same as what we've just been doing. on the previous ones. So for part B, the points where A and B, where it cuts the y-axis, that's where x equals 0. Okay, so we're going to set the x parametric equal to 0. Oops, keep accidentally pressing with my hand. So cos t plus sine t equals 0. Okay, so this is why this question is a bit more complicated, because we're now having to solve a trig equation. Okay, so this is where this topic of parametrics, there's lots and lots of different things and skills involved. So now we're solving a trig equation. So we need to think about how we would normally solve that. Well, if we've got a cos and we've got a sine. So if I divide everything by cos t, so if I divide that by cos t and that by cos t divided by cos t is 1. Sine t over cos t is tan t, which gives me tan t equals -1. Okay, so we need to solve that. So if we get our principal value, inverse tan of -1, the principal value is going to be -π/4. Okay, so if I consider, just do a little mini cast diagram. So tan is negative in the sine quadrant and in the cos quadrant. So that's going to be π/4. That's going to be π/4. Okay, we only need to consider values for t in the domain of the parameter. So between -π/2 to 4π/3. Okay, so we only need, we can just change colour. We only need that angle there. So 4π/3 is just over halfway in an anti-clockwise direction. So we're going to need that angle there, and -π/2 is just in that first quadrant, but in a clockwise direction. So those are the two angles that we need. So t is going to be 3π/4, that's for the red one, and t is going to be -π/4. So we've worked out the parameters, the values of the parameters where the graph is crossing the y-axis. So we know x is 0, so now we just need to work out the value of y at the two different parameters. So here, so I'm just going to substitute 3π/4 into my y parametric. So y equals 3π/4 minus π/6 squared. So if we stick that into my calculator, okay, that's going to give me 25 pi squared over 144. Okay, if your calculator can't cope with that and leave your answer in terms of pi, then just do 3/4 minus 1/6, square that, and then put the pi squared next to it. Okay, so that's the point 0, 25 pi squared over 144. And then if t equals minus π/4, y will equal minus π/4 minus π/6 squared, substituting it into the y parametric. I think I've got those mixed up. That should be 25 pi/4, pi squared over 144. apologies, got my points mixed up. That one should have been 49 pi squared over 144. I looked at the wrong one in my notes. So the first one, when t is 3 pi on 4, we get 49 pi squared over 144. When t is minus pi on 4, we get y is 25 pi squared over 144. So that gives 0, 25 pi squared over 144. Okay, so some funny numbers, but doable. Okay, so A is the smallest, so that one must be A, and that one must be B. Okay, that's the end of that video. In the next video, we're going to be looking at how to use this sort of situation, this type of maths, but when it's involved in some sort of context.